Hi, welcome to my science class. This is teacher Christine from Rodolfo V. Feliciano Memorial High School. We are now to talk about the third topic for this quarter, which is the periodic table of elements. But first, let's have a review. In the previous topic, we learned about elements and compounds. Once again, an element is the simplest form of a substance and is made of only one kind of atom, while a compound is a combination of two or more kinds of atoms. We also learned about the properties and importance of elements and compounds in our body. In this lesson, we will learn about the different kinds of elements around us. And the best tool to learn these substances is the periodic table of elements. This is how the periodic table of elements look like. Now let us have the definition. The periodic table of elements is a tabular arrangement of the chemical elements. It is organized in order of increasing atomic number. It is developed so that scientists can quickly determine the properties of individual elements, such as their atomic mass, atomic number, and their unique chemical properties. Atomic mass refers to the number of neutrons, or also known as the uncharged particles, contained in an element, and the number of protons, or the positive charged particles in an element. As for the atomic number, it refers to the number of protons or electrons in an element. And as mentioned here, the elements are organized in the periodic table of elements according to increasing atomic number. Therefore, the atomic number indicates the position of the element in this table. Now let us move on to the next part, which shows how elements are grouped in the periodic table of elements. As we could see in this illustration, the periodic table is divided into columns and rows. The vertical columns in the periodic table of elements refer to the groups or families of the elements. And looking at the number of the columns or the groups in this table, we have 18 groups of elements or 18 families. As for the horizontal rows, these are known as the periods. Now we could count the number of periods here and we will come up with 7 periods. Identifying the position of the element in the periodic table is easy if we will just base it according to the group number and the period number. Aside from being classified into groups and into periods, elements are also classified according to their properties. Now, based on their properties, we could classify them based on being metals, nonmetals, and metalloids. Now, let's talk about metals. Metals are elements that are solid at room temperature. Mercury is an exception, since it could maintain its state of being liquid even at room temperature. Metals are usually shiny. That's why we could use them as materials for making jewelry. They also have high melting point, meaning it's not easy to melt this kind of materials or this kind of elements. They are also good conductor of heat and electricity, which mean that they are materials that can allow heat and electricity to pass through. This is also the reason why metals are used in house wiring. Metals are also known as being malleable, So they could be pounded or they could be hammered into sheets without breaking. They are also ductile, meaning they can be pulled into wire. Now, examples of metals we have magnesium, beryllium, calcium, strontium, barium, and radium. Metals can be classified into the following families. So we have alkali metals. We could find them under group 1. Alkaline earth metals, they are found in group 2. We also have transition metals. They are from group 3 to group 12. And the rare earth elements, they are found in those two periods that are separated from the table. Well, we could know them as the lanthanides and actinides. And we also have the poor metals. They are located on this part. So those are the different families for metals. Now moving on with nonmetals, these are the elements that are either gas or solid under standard conditions. So we have examples of nonmetals: hydrogen, oxygen, and nitrogen. Those are the elements that are in their gas form under standard conditions. And as for carbon and sulfur, they are in their solid forms. Opposite from metals, nonmetals are not good conductors of electricity or heat. That is the reason why they are used as insulators, since they do not allow electricity and heat to pass through. If you will notice your wirings at home, they are covered with some kind of rubber or plastic. We could consider those materials as nonmetals. Nonmetals are very brittle in their solid form, so it's easy to break this kind of materials. Unlike with the metals that no matter how you hammer it or hammer them or to pound them, they won't easily break. Non-metals are not malleable. They are not tactile or ductile as well. They have lower melting and boiling points than metals. But one exception is carbon. So it doesn't have a low melting and boiling point. These are the classifications of nonmetals. So we have the non-metals is in hydrogen group. So we have hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. Then we have the halogen group, which includes fluorine, iodine, bromine, and we also have the noble gases. Now, as for the noble gases, it was said that these are already stable elements. It has something to do with their number of electrons in their outer shells. Now, those are the classifications or families under non-metals. Now, for the next classification or group, we have metalloids, also known as semi-metals. So these elements possess or show partly the characteristics of metals and partly the characteristics of nonmetals. That is why they are known as semi-metals. Their reactivity depends on the properties of the other elements in the reaction. They are often good semiconductors, but not as good as metals, of course. They often have metallic luster, so some of them also have shiny appearance, but they have allotropes that appear non-metallic. They usually behave as metals or non-metals in chemical reactions. They have the ability to form alloys with metals. They are usually brittle. They are usually solids under ordinary conditions. Now here are just some of the metalloids in the periodic table. So we have boron, arsenic, and silicon. Well, actually, we only have, to be exact, seven elements in the periodic table, which are considered as metalloids. So as you can see, they are between metals and nonmetals. Now, those are the different things that we have, or we could consider when we talk about the periodic table of elements. Regarding the development of the periodic table of elements, those ideas will be discussed in the next grade levels. So thank you for listening. I hope this video helped you in understanding the basic concepts of the periodic table of elements. See you in the next class. Bye!